Hello students, there is another sample problem video on beam deflections designed to be used or to be solved using your calculator capable of solving simultaneous four unknowns linear equations. So here is the problem by matrix approach. Determine the nodal displacements and member forces and support reactions. EI is constant. So these orange colored values are the fixed moments, fixed forces also for this light yellow-green colored. So for this part, counterclockwise, due to the load or negative moment from slope deflection equations, WL square over 12, 30 times 4 square over 12 is 40. So it's also 40 on the other end. While this fixed force upward of 60 is 30 times 4 divided by 2 because of symmetry. So 30 times 4 divided by 2 is 60 kilonewtons, 60 kilonewtons. For portion BC, the fixed moment here is counterclockwise or negative W 30 times 6 square over 20. So 30 times 6 square over 20 is 54. I hope that the viewers already know that the fixed moment is WL square over 20 for triangular loading at this end with load intensity. And at the zero end, WL square over 30. So 30 times 6 square over 30 is 36 kilonewton meter. So for this fixed force, we sum up moment about C. So fixed force BC times 6 plus 36. So you write the equation equals 54 plus moment of the load 1/2 of 6 times 30 times moment arm 4. And you will get 63. This 27 can be solved also by summing up moment about B, or the best way is, if you're sure that this is 63, you just sum up forces vertical. So it is 1/2 of 6 times 30, which is 90. 90 minus 63 is 27. So we just leave D at ease because the joints or supports with displacements or joints with or nodes with displacements would be B, C, and D. There are 4 unknowns, 1 at B, the rotation at D, the rotation at C, another unknown, so 2. The deflection and rotation at D, so that makes it 4. And the numbering would be 4, the unknowns would be U4, U6, and 7 and 8. U7 and U8. U4 is theta B, U6 is theta C, and U7 delta D, U8 theta D. So the stiffness of AB is factor out EI. Then we have here 12 EI, 12 times 1 over 4 cube, so 3 over 16. 6 EI, 6 times 1 over 4 square, 3/8. Then the negative of 3 over 16. Then you just copy 3/8. Then the next row would be 6 EI, 6 times 1 over L square, 4 square, 3/8 also. So you just copy that. This is 4 EI, 4 times 1 over 4, so that's why 1. This is the negative of this value here. And this is 1/2 of this 1 here. 1/2 of 1 is 1/2. Then the next row is the negative of the first row. The last row is you copy the second row, except that we interchange position 1 and 1/2. So 1/2, 1. So that's it. That's the technique. For those who are students in matrix structural analysis, you already know this. But for those who are beginners or not students in matrix you have to study matrix first, the principle and the global stiffness matrix of an element, which is the mentioned formulas as mentioned earlier. So KBC 12 EI1 over 6 cube is 1 over 18. 6 times 1 over 6 square is 1 over 6. Negative 1 over 18. Copy 1 over 6. Then 1 over 6. 4 times 1 divided by 6 is 2/3. Negative of this value, 1/2 of this 2/3 here, so 1/3. The negative of the first row, copy the second row, interchange position 2/3 and 1/3. So that's KBC. Finally, KCD 12 over 2 cube is 1.5. 6 over 2 square is also 1.5. The negative of this value, then copy that cell there. Copy 1.5. 4 times 1 over 2 is 2. Then the negative of this value, 1/2 of 2 is 1. The negative of the first row, then second row copied, interchange position. So this is 1 here, 2 there. So that completes. So the unknowns U4, U6, U7, U8, 4, 6, 7, 8. These are the nodal forces opposite to this. But since A is fixed, we begin with this part. 40 clockwise minus 54 is negative 14. So, or in other words, 14, the net fixed end moment is 14 counterclockwise, but the nodal load is opposite to the net fixed force, fixed moment, so it should be 14 clockwise, and 14 clockwise is negative here, F4 in the solution, because the global sign convention is counterclockwise positive. At node 3, the moment is 36 clockwise, so opposite to that is counterclockwise, so that's positive 36 F6. Then at 4, we only have negative 15 downward, 0 moment at B. Then, also if you compute the fixed moment, it's really 0 here, because we imagine that C and D are fixed. So the 15 kilonewton load acts on the fixed end, so it has nothing to do with the moment, but there is reaction here which is also 15, and the load is opposite to upward reaction which is 15, so that's why it's negative 15 downward, no moment. And this is the value of the cells for 4, 4, we have 1 here plus 2/3. 1 plus 2/3 equals 5/3. 4, 6, 4, 6. 4, 6, we have 1/3 here. No here, so 1/3. 4, 7, there's no 4, 7, no 4, 7, so 0. 4, 8, there's no 4, 8, no 4, 8, 4, 8, so 0. Then copy 1/3, 0, 0 because of symmetry of the system structural matrix. Then this is 6, 6, 6, 6. We have 2/3 here plus 2, 2/3 plus 2 is 8/3. Then 6, 7, row 6, column 7. 6, column 7, negative 1.5. That's why we have negative 1.5. 6, 8. 6, 8 is 1, so we have 1 here. Then copy negative 1.5, copy 1. 7, 7, we have 1.5 here. So 1.5. Then 7, 8, 7, 8, negative 1.5. Negative 1.5, copy negative 1.5. This is 8, 8, 8, 8. Just this one, there's no 8, 8 here. 2, so 2. Therefore, U4, U6, U7, U8 can now be computed as the product of the inverse of this matrix here and the force matrix here. So the result, U4, which corresponds to theta B, U6, which corresponds to theta C, U7 delta D, and U8 theta D is equal to, respectively, negative 11.3333 over EI, 14 point theta C, 14.6667 over EI, delta D, negative 10.6667 over EI, and theta D, negative 15.3333 over EI. Then we can now compute member forces for shear AB, which is RA, in particular, moment AB, which is MA, shear B left or shear BA, then moment BA. So this is the stiffness of member AB. We just copy this. Then the displacement delta A is 0 because that's fixed. Theta A is 0. Delta B is 0. And this is theta B, which is negative 11.333 over EI. So VA or RA is 3/8 times negative 11.338 plus fixed end forces. So fixed end forces would be 60, positive 40 because this is counterclockwise. Then at the right end 60, positive 60, then negative 40 clockwise, so negative 40 kilonewton meter. So RA is 0, 0, 0 because we have 0 here. 3/8 times negative 11.3333 plus 60 equals 55.75. Moment AB is 1/2 times negative 11.3333 plus 40, that's 34.3333 kilonewton meter. Shear BA, or shear just to the left of B, is negative 3/8 times negative 11.3333 over EI, so cancel, so negative 3/8 times negative 11.3333 plus 60, that's 64.25. Then finally, moment BA, 1 times negative 11.3333 minus 40 is negative 51.3333. Then we proceed to BC. So this is the stiffness of BC, EI times this stiffness, we just copy. Delta B is 0, theta B negative 11.333 over EI. Delta C is 0, then theta C 14.6667 over EI. So plus fixed end forces 63, positive 54, then on the right end 27, then negative 36. So shear BC is 1/6 times negative 11.333 plus 1/6 times 14.667. We bypass 1 over 18 times 0, negative 1 over 18 times 0 because the result is 0. So 1/6 times negative 11.3333 plus 1/6 times 14.6667 plus 63, then you'll get shear BC 63.556. Moment BC 2/3 times negative 11.3333 plus 1/3 times 14.6667 plus 54 is 51.3333 kilonewton meter. Shear CB is negative 1/6 times negative 11.3333 plus negative 1/6 times 14.6667 plus 27, you'll get 26.444. And moment CB is 1/3 times negative 11.33333 plus 2/3 of 14.6667 plus negative 36, so you'll get negative 30 kilonewton meter. Finally, for CD, we have stiffness of CD copied, then displacements delta C 0, theta C 14.667 over EI, which is this, then delta D negative 10.6667 from the preceding slide, then theta D negative 15.333 over EI. Then fixed forces, this will be the fixed forces, 0 force reaction, 0 moment, then 0 moment, positive 15. So 0, 0, positive 15, then 0 moment. So Shear CD 1.5 times 14.667 plus negative 1.5 times negative 10.667 plus 1.5 times negative 15.3333 plus 0. The result is 15. So that's expected. Then moment CD 2 times 14.667 plus negative 1.5 times negative 10.667 plus 1 times negative 15.3333 plus 0. That's 30 kilonewton meter. Shear DC negative 1.5 times 14.667 plus 1.5 times negative 10.6667 plus negative 1.5 times negative 15.3333 plus 0. And that would be shear DC negative 1.5 times 14.667 plus 1.5 times negative 10.667 plus negative 1.5 times negative 15.3333 plus 15, that would be 0. Then moment DC 1 times 14.667 plus negative 1.5 times negative 10.6667 plus 2 times negative 15.3333 plus 0 equals 0. So if you want to solve for reaction at A, that is just shear in AB, and that was 15.75 kilonewtons. RB is shear BA plus shear BC. Shear BA is 64.25 from the preceding slide. Shear BC is 63.556, adding, so you'll get 127.806 kilonewtons. R sub C is shear CB, which is 26.444 plus shear CD, which is 15, 26.444 plus 15, 41.444 kilonewtons. So that checks, and these are also the answers in the lecture part, solved by superposition method.